Hello everyone, and I welcome you all in this learning video where we are going to solve problems on homogeneous linear partial differential equations with constant coefficient. Okay, so let us see this problem. Now as you can see, this problem is having right hand side 0, right? So solution of this equation would be just a complementary function. So let us find out the complementary function of this. Okay, so you can start like the given equation is what is this given equation? D square plus 3d d dash plus 2 d dash square operating on z is equal to 0. So what is this? This is homogeneous linear Pde. Okay, so if this is homogeneous linear Pde, write down its auxiliary equation. So its auxiliary equation is, what is its auxiliary equation? Put d is equal to m and d dash is equal to 1. So just because this is the very first problem, let me write for auxiliary equation, put d is equal to m and d dash is equal to 1. We get, so what will be getting? We'll be getting m square plus 3m into 1 plus 2 into 1 square equal to 0. Okay, forget about this. For in the auxiliary equation there should not be a dependent variable. Okay, now find out the roots. So roots are for m square, m into m, roots of 2s, 2 into 1, 1 into m, 2 into m, 2. So 1 plus 2, 3. So I can write this one as m plus 2 into m plus 1 equal to 0. That is, what is my m? M is equal to minus 1 and minus 1. Once you get the roots, you just have to write down the complementary function. Therefore, CF is equal to phi 1 y minus 1x plus phi 2 y minus 2x. Don't forget to write. Okay, this is just the complementary function. Okay, therefore the complete solution is what is it? Y is equal to CF, that is y is equal to phi 1 y minus x plus phi 2 y minus 2x. Don't forget to write where phi 1 and phi 2 are arbitrary functions. Okay, so this is nothing but the solution of the of this problem. Now let us take more problems on this. So let me change the problem now. So the problem is solve 4r plus 12s plus 90 is equal to 0. Now we have to get the solution of this equation. So what is my given equation? Now if you are not getting the filling of partial differential equation, these are nothing but the notation. Do you remember the rule of this 5? P, this is P, small p, that is del z by del x. This is small q, del z by del y. This is r, small r, del 2z by del x square. This is t, that is del 2z by del y square, and this is s, del 2z by del x del y. So this is r. So you can write this equation as 4 del 2z by del x square plus 12, what is s? Del 2z by del x del y plus 9, what is t? Del 2z by del y square equal to 0, right? Now, you know what is this? This is nothing but, I am writing here only, that is 4d square plus 12d d dash plus 9d dash square. Give me a space, I will write it properly. This is that is 4d square plus 12d d dash plus 9d dash square equal to 0. And what is this? This is nothing but the homogeneous linear PDE. So to get the auxiliary equation, we put d is equal to m and d dash equal to 1. So what will be getting? We'll be getting 4m square plus 12m plus 9 is equal to 0. So 4m roots factors for 4m is 2m into 2m and factors for 9 is 3 into 3. 2m into 3 6m and 2m into 3 6m. 6m plus 6m 12m. Okay, if you are not getting this trick, so you can find it on your own or you can find it with the help of calculator. So what is now my roots? So factors are 2m plus 3, 2m plus 3 is equal to 0. So what is my m? M is equal to 2m plus 3 equal to 0. So minus 3 by 2, minus 3 by 2. It is like 2m plus 3 equal to 0, 2m is equal to minus 3, m is equal to minus 3 by 2. Okay. So now I am having root like minus 3 by 2, minus 3 by 2, right? So what is my CF? CF is equal to phi 1 y minus 3 by 2x. Okay, y minus 3 by 2x. Now as the root gets repeated, so x power 1, okay, into x phi 2 y minus 3 by 2x. Okay. And once you write the complementary function, you can able to write down the general solution or the complete solution y is equal to CF. Now see, this can also be written as okay, let me write like phi 1 y minus 3 by 2x, then x into y minus 3 by 2x. Okay. Why I am writing minus? Because I am having negative roots. Okay. Now same thing you can write like, just a remark. We have this complete solution y. Now this y can be written as y is equal to f of 3y minus 2x. Sorry. This is like, take the LCM. 2y minus 3x by 2. So by 2 is absorbed by this phi 1 and I am writing some different function f1. Okay. Plus x into f2 2y minus 3x. Okay. If you write up to this, that is also correct. This is the more precise answer. If you want, you can write. If you find this difficult to write, then don't write. This is also acceptable. Okay. Now let us take one more problem. Solve now we have one more problem. So let me take that problem. Yeah. So solve d3 or del 3z by del x cube minus 4 times del 2z by del x del y, or let us take it 2 to make it more interesting, is equal to 0. Del 2z by del x, sorry, this is del 3z by del x squared. Okay, fine. So we have this given equation, then try to write this given equation in terms of d notation. Okay, so what is this stand for? This stands for d cube minus 2 d square, square for this x square, and for this del y we have d dash operating on z is equal to 0. Okay, clear? So we have this equation. This is homogeneous linear Pde with constant coefficient. Its auxiliary equation can be found out by putting d equal to m and d dash equal to 1, and we will get we get, what is it, m cube minus 2m square is equal to 0. Now you can take m common from here. We'll be getting m square, okay, m square common from here, we'll be getting m minus 2 equal to 0. So what I am getting now, I am getting m is equal to 0, 0 and plus 2. Okay, now once I get the root like this, I can able to write down the complementary function, right? So as you can see here the roots are repeating, okay, 0, 0. So I will write phi 1 as y plus 0x plus, because 0 is repeating, so I will multiply by x into phi y plus phi 2 y plus 0x, and we have another root 2 which is not repeating, so I can write phi 3 of y plus 2x. Okay, now you can write this as phi 1 y plus 2x. Let me write here, or I will write the same as CF is equal to phi 1 y plus 2x plus phi 2 y plus 0x plus x into phi 3 y plus 0x. I have already told you that you can write complementary function for this root first and then this, that is also okay. Okay, now once you get CF, write down the general solution. So what is the general solution? General solution is y equal to CF. Write down the CF and don't forget to write where phi 1, phi 2 and phi 3 are the arbitrary functions. So in this lecture we have taken 3 different kinds of example. I hope this is clear to you. If you have any doubt, you can contact me, and thank you for watching this learning video. Enjoy learning mathematics. Thank you.